Good afternoon, everybody. Today we'll be studying acid and base that we left off last class in here. But before we go to acid base, I would like to get started with a little bit recap of chapter 4 that we talked in last class. The difference between chapter 3 and chapter 4 is only one specific point is solution. Chapter 3 we calculated same as we're doing in this chapter, but chapter 3 we calculated from gram of a substance to gram of other substance in a chemical equation. But in this chapter, we solve problem and we'll be solving more problems on solution. We're starting from a volume or gram, and then we go to mole, and then we will calculate unknown gram or volume or concentration. But chapter 3 we did not do any calculation with the volume and concentration. That we will do in the chapter. So let us start with the acid and base. What is acid and what is base in your term?
Acid as a hydrogen.
Acid as a hydrogen, right? That's a very key thing we know first, that acid has a hydrogen, but all acid doesn't have a hydrogen. Sometimes acid doesn't need hydrogen, sometimes being with a hydrogen still not acid. Okay? There you go. First formula is Arrhenius acid formula. Mr. Arrhenius, he was awarded Nobel Prize, the third chemist who Nobel Prize winner, and he gave the first definition of acid. He was the one first said what acid should be. Also base. So first thing, as I said, acid. Acid is a substance, is a compound which can donate H plus, or which can increase concentration of H plus in a solution. So as example, HCl, which we always use as a common example, HCl, this compound have H in the left side. So this is also common in acids. The left side usually H is located, which is donatable, which dissociate. If you dissolve in water, that will be H2O plus chloride ion. So you see what happened here. This compound donated H plus to water and H2O plus form, and acid become chloride ion. So by definition, any compound is increasing hydrogen ion concentration in a solution, that's called acid. So this compound is acid because this donating H plus to water, and this become a base. So we'll talk about later. But at this moment, acid is this, based on the Arrhenius. What is base? Base is a compound which can donate OH ion. So sodium hydroxide which have OH ion, and this is donatable. So based on Arrhenius, any compound has OH have to be on the right side. That's called base. So as I said, let's go back to acid. Acid is a H, but sometimes there is a H in the left side, still is not acid. Any example?
H2O.
There you go. In there, right? This is not acid even though it has a H, because it's not donating, rather it's accepting H plus from acid. That's called acid. And sometimes H could be right side. For instance, sodium hydride. In this compound, H is not as acidic H. This H is not acidic. this is not donatable. So this is a purely ionic compound. Because if you remember in the periodic table, H is located on the top of group 7A, which is, that's why H a lot of time working as a negative ion, H minus, right? Acid base. So this definition, even though very first discovery, but this definition is a little bit limited. The second definition is Bronsted-Lowry. Bronsted-Lowry is the one explain better understanding of acid. Bronsted definition is any compound donate H plus as a proton. The same H, H2O, this H2O have H plus and hydroxyl minus. The same H plus that HCl has. But Bronsted-Lowry, they define it as a proton instead of calling hydrogen ion. Can you call it proton? Can you call this guy proton? Yes, you can. Think about it as a hydrogen atom. What hydrogen atom has? How many electrons it has? How many protons it has? One as well, right? But when it becomes H plus, what happened with the H? Just lost electron. That means it doesn't have any more electron except only one proton. So that's why being only one single proton, not having any electron, is called proton. So proton dissociated from water. So any compound can donate H plus, that's called acid. So by this definition, this compound also acid. Yes, because this donating H plus to water. This compound also acid, because this also can donate H plus. So this is also acid. And the base is any compound can accept proton. That's called base. He did not go with a OH formula. Bronsted idea is any compound has ability to accept proton, that's called base. Can you see any example in here, any compound accepting H plus, accepting proton? H3O actually donating H plus. H2O, this is the one accepting H plus proton, which is called proton. This water is the one accepting proton from this HCl. So this is called a base. Now tell me two other compounds. What happening with those guys? H3O, what is doing? Accepting H plus or donating H plus? Donating. So this will be acid. What happened with the chlorine? What chlorine did with the here to here?
Give away hydrogen.
What did the chlorine do? Accepting H plus. Donating H plus, yes. So, no, accepting. I said from here to here, look at the arrow.
Yes.
So it accepting H plus. So accepting H plus is a acid or base. Look at that screen.
Base.
So donating H plus is acid, accepting is a base. Based on which formula? Arrhenius or Bronsted-Lowry? Bronsted-Lowry. So this is also a base based on Bronsted-Lowry. Right? Okay. We have three more compounds we didn't mark. So this water is acid or base. Is dissociating H plus or giving, donating or increasing H plus. This is going to be acid, exactly. How about this plus, this H plus? What is doing from here to here? Accepting what? OH. It was H plus. Why you cannot answer? what happening from H to H2O? Just look at it. Look at that, it accepted OH. Right? So accepting OH is a acid. We're going to go back to the Arrhenius. How about these guys? What did these do? What did this OH do? Or then it's acid or base?
That means a base.
Base. So we need to know one more thing. First thing we need to know if see an ion or compound, whether it's acid or base. Second thing we need to know what types of acid it is. Is it Arrhenius or Bronsted? Let's go. Is it acid based on Arrhenius or Bronsted?
Sorry, yes.
Arrhenius, right?
Yeah.
You're right. Who said Bronsted? You're right too.
What is the first one?
Arrhenius is any compound donating H+. Bronsted is any compound donating hydrogen, donating proton. This compound donating H+, so Arrhenius acid. And this compound also donating proton, so this is Bronsted acid. When it comes to base, definition is different. Two different opinions. Arrhenius is any compound donating OH, like this one. This is the base according to Arrhenius. But this is the base according to Bronsted-Lowry, because it's accepting H+, which named as a proton. So accepting proton, this compound becomes a base. This compound is a base, but not based on Bronsted-Lowry. So compound should have a basic property based on two different definitions. So do more practice. In exam, you don't need to make your own equation at this level. At this level, you'll have equation. You need to recognize which one is acid and base. Okay? Any question? We talked about strong acid and strong base, strong acid and weak acid. Who are the weak acid I said? Who are the weak acid? How do you know weak acid or not if you see a compound? We talked about last class. How do you know a compound is weak acid? If you see a compound, right? HCl, is it weak acid, strong acid or weak acid? So HF, is it strong or weak? How did you know it's weak?
Anything that's not there.
Exactly.
Yeah.
Folks, I talked about that. Anything is not in the list, it's going to be weak. There you go.
You said we have to memorize those, right?
You should memorize them, yeah. Remember we said, we talked about that. You can make a formula to memorize or just memorize them. Polyprotic. Polyprotic is any compound which is acid and it has more than one H in the left side. More than one H in the left side. That means it has ability to donate more than one proton. Right? HCl can donate only one. Comes to sulfuric acid, it can donate 2 protons. So polyprotic acid. And strong base. How do you know weak base?
Down a strong base list.
Not on the list. There you go. Okay. Okay. Potassium hydroxide is strong or weak? Strong, because it's on the list. Hydrogen sulfide is a acid or base? Acid. Strong or weak? Weak. It's not on the list. Then methylamine is a base. How do you know this is a base? Yeah, hydrogen is not on the left. It's not started with the hydrogen, right? And next one, chloric acid. It is strong and it's on the list. So it is strong acid. How about HI? Strong acid. Now we move on to the new topic today is molarity. Molarity is so by definition, molarity is number of mole or moles in 1 liter solution. How many moles you have in 1 liter solution? That's the molarity. So molarity is a type of concentration. So type of concentration, what M stands for? M stands for molarity, which is N, which is number of mole, and volume in liter. So number of mole and liter. So this is the new equation we have in this chapter. That's all. Everything else is same that we talked in the previous classes. So by at any time, if you get number of mole, can you calculate gram for the mole from mole? How? By dividing molar mass, right? Is it? Multiply. Trying to trick you guys. Think about it again. How do you get molar mass from mole? Multiplying or dividing by molar mass. So if you get 2 mole, right? 2 moles. From 2 moles equal to how many, say, for instance, oxygen, 2 moles of oxygen, okay? Equal to how many gram? 32. How did we get it? 2 times 16, not 2 divided by 16, right? Okay. So in here, same thing, we'll get number of mole first, we'll calculate that. Then we'll need to calculate either volume or molarity. How do you get molarity? You dividing by volume in liter. If you want to get volume in liter, then you just number of mole you have and dividing by molarity. Right? These 2 equations you need. Before we go into the new this stoichiometry calculation, let's get some practice problem with the molarity. Solve this one. You have a 4 gram of sodium hydroxide and 500 milliliter of sodium hydroxide. What is the molarity? The solution. So you need to calculate molarity, and you have 4 grams sodium hydroxide and 500 milliliter sodium hydroxide. So this is the equation, right? Calculate molarity, you get number of mole over volume in liter. Do we have number of mole in here? Can you get it? Number of moles sodium hydroxide? Yes, from gram to dividing by molar mass. Do not forget that anybody write on the board, you get extra credit always.
I'll do it.
Yad or Iran? I forget. I forget. Yan.
Yeah.
Okay.
Chop.
Chop. Yeah. It is 500 milliliter.
Oh wait, let's, no, I see the point there. Is that a final or period?
That's a period. That's just for or it's, yeah. That's not 5,000. Get 3 quick samples here. We got 1 over. Oh, you have to get 1 over. It should be 1 over that.
Okay, 5 gram of sodium hydroxide dividing by 40 gram. Then we got. Okay. Yes. Then
Should be 1 over though, 1 over 5,000.
Yeah, it has to be liters. You have to convert milliliters to liters.
Oh, actually, you're right. So it's almost a milliliter.
Oh,
so 4.0 gram of sodium hydroxide. Right. Then there is some students wrote in exam like this way. Some of them you got totally 0, some of them got partial credit. Because this is okay for this time, but not for exam, okay? So it doesn't mean anything to me. I don't know what you're talking about, 4 gram of what? Why are you dividing by 40? What did you mean with this? I do not try to understand that you mean sodium hydroxide. So I want to see that what's in your head, you wrote it up. So 4 gram of sodium hydroxide, then 40 gram sodium hydroxide, 1 mole of sodium hydroxide. And then you dividing, you got the mole you're dividing by volume in liter, right? Volume in liter, right? So what is volume you have? So 1 over 500 milliliter, right? But we said that for molarity have to be in liter. How can you convert that volume to the liter? You need to divide by 1000, right? So again, multiply this sign, you don't have to do that. And then to make, so 1 liter equal to 1000 milliliter. Look at I multiplied that. But I said that I'll divide it. So if you dividing in here, it actually multiplying. And that's the one way. Second way, you think that your goal is to get to mole per liter. You got mole in the top, your goal is liter in the bottom. Put 1 liter in the bottom, so it's automatically milliliter coming on the top to cancel that out.
And what's that 1 above the 500 milliliters? It's just the 1.
Just
It's 1
because
over
of the
500.
yeah, that's a very good question. Why I'm saying that? Yeah,
Okay.
because we are dividing. We are dividing. That's why I put it 1 over. Then I got concentration of this sodium hydroxide in this solution. You can do this way. First you gram go to the mole, right? Then volume you convert to the liter. Then you use the formula which is mole over liter. You see? Both ways. Now you see which one is easier for you. To me, this is make more sense because you just need to put in an order based on what you need to put. Since all of the calculation we have been doing with this format, right? In dimensional analysis, and you do that. But what if you have multiple choice questions? Then simply do in your head. You don't put anything for me, right? I just need answer from you. Try one more? Okay.
Yeah, this is more weird, that's where it comes from. And weird is this one. It was,
Go ahead.
So when we went,
Go ahead.
we're putting like the wheel at the very end, milliliters or how I saw on the board, that's why I asked going to find it.
You can put mole per liter or molar. Both, either one is fine. Because both means the same.
Which is this?
So we got it, we got it. Okay, so now you can calculate the molarity, right? Okay, if you can do that, let's go to the next section is dilution. This molarity, you can dilute it up. For instance, do you dilute something sometimes? Do you dilute sometimes something? Right? What do you dilute? For example, like real life example, cheese, juice,
Tea.
tea. Tea, you dilute it?
Yeah. You put it in water, like if you brew it. And then
Right.
put it,
Okay.
you can do that.
Juice too, right?
Juice.
Sometimes you don't like to take too strong sugar, right? Make it like diluted. Yes, we do that. Yes, in chemistry we do that too. Like the acid, we're talking about the HCl, hydrochloric acid that you do in the lab, or any chemical you work in the lab with, like next lab you'll be working with titration. So you get acid and base. The acid and base that what you use that is very low concentrated and very diluted form. So this diluted acid came with a stock solution, which in chemistry called stock means like the one we got. The one is highly concentrated. So in stock solution, usually high concentrated, and we need to dilute it up to as needed. So how do you dilute it up? For instance, this flask I have very small amount left. For instance, 100. I have 100 milliliter of HCl, very diluted, very concentrated, which is maybe 10 molar, right? We never use 10 molar hydrochloric acid solution. To use it up, to make it, so we need to dilute it up to maybe 2 molar, right? So the water was 100 milliliter, and 100 milli we convert to bigger volume by adding more water. So how much water we need to add? Isn't it would be very good if you know some formula to use have a formula, plug the value, and just get the volume how much you need to convert from 10 to 2 molar. That would be great, right? Yes. There is a formula which is called M1 V1 equal to M2 V2. By using this formula, we can calculate how much volume we need. Or if you dilute it to certain amount, now what is the concentration? You can calculate concentration, you can calculate volume as needed. So, this is bottle 1, bottle 2. So, this volume is initial volume since bottle 1, volume 1. This is the one, M1, right? M1, V1, first initial concentration. This is the concentration of bottle 2. Now the question is, what is the concentration of, what is the volume of V? That means how much water you need to add. Two questions could be, how much water you need to add to make it to 2 molar? Or what is the final volume you need to change 10 molar to 2 molar? Look at that. Plug in all 3 value in here. M1, V1, you got M2 as well, just into V2. So, what is M1? Is 10 molar, right? 10 times V1 is 100. And then M2 is a 2. V2, you need to know what is the final volume.
You don't have to worry about the 100 being in milliliters, not in liters.
Have to be? Very good question. Do you have to worry about it?
No.
No, why not?
Because you can't, you have to convert it first.
Because both sides are equal. See what I'm saying? Both sides same. So, and then you divide both of them by 2, both sides by 2, right? Then V2 equal to 500 milliliter. If you use V1 as a milliliter, you will get V2 as a milliliter too. So you added, you started with a 100 milliliter acid that ended up with a also milliliter form. So if you like to make it 0.1 by dividing 1000, that will be 0.1, right? So put it in here. So 10 times 0.1 equal to 2 times V1. Right? So divide by 2, you see, divide by 2. So now V1 equal to, what do you get here? 0.5. So this was a milliliter, this was a liter. Actually same. It depends on, if multiple choice question in exam, then depends on what you need. That's like this. I would encourage you, do not convert in here until you need to. Like, for instance,